Selection problem. We know selection problem, but this time our data is different. The data, it is not a usual unordered array. It's not that. The data is in union of two sorted arrays. Union. So we have two sorted arrays. So we put them together. So that's all the data we have. Now we need to do the selection problem. Find an element with given rank. The rank, we use that concept. The smallest element, rank 1. The second smallest, rank 2, and so on. Yeah. All right, so let's look at this. Problem number 18. Selection problem for two ordered arrays. Given two sorted arrays of lengths m and n. Okay. Find the kth smallest element in the union of the two arrays. The union. Okay. So we use the basic union concept. Union of two sets. Yeah. But we do not really do the special operation to merge two arrays. Yeah. Although you can do that, but that may not be a good way to do it. Yeah. So let's do some analysis. Take advantage of the order information in the data. The order always very important. When you have ordered data, a natural way to work on your data, the binary search. The most commonly used method, binary search. Yeah. All right. The question, how to use the order information? Here we have two ordered arrays. And we may not like to merge these two arrays because the reason the cost is relatively high when you merge two ordered arrays based on our merge step. The worst case, m plus n minus 1, right? Worst case, when you merge two ordered arrays. That's the cost. All right. But if you use the binary search based method, we can get a log base 2 function. That would be better than this, log base 2. So our goal, we set our goal, big O of log of m plus log of n. So you can see this goal is much better than that merge-based solution. Merge-based solution. So we want this log function, for the efficiency. Yeah. So that means it is not easy. It is challenging a little bit. Yeah. All right. So so we saw that the merge, the cost too high, so we don't like it. Yeah. So now we want to work on two ordered arrays directly without merge them. Work on two arrays simultaneously. Yeah. All right. Facing the challenging part. Let's look at the, selection, the challenging. How do we make right selection? Without merging the two arrays, we need to develop a way to help us figure out the kth smallest element. Key step, apply the binary search on two sorted arrays. We're not using binary search, but here we have two ordered arrays. How do we apply binary search? That's not easy. The hard part is, how do we apply the binary search on two ordered arrays? That's the challenging part. Yeah. All right, so need to carefully manage the rank number k. How do we manage this or control this rank number k? Yeah. All right. Get some idea from a visual, yeah. So let's draw a diagram, visual representation, yeah, for better understanding. The first array, this long, second array like this, yeah. So let's work a little bit on some simple cases first, yeah. Because that's our commonly used problem-solving strategy. Simple cases. All right, start with the simple cases. That's the easy step. Okay, yeah. Let's choose the easiest possible case first. What's that? K equals 1. Smallest. Rank 1. The smallest element. That's the easiest. Right? Okay. How to solve it? How many comparisons do we need for k equals 1? That's easy. Okay. Trivial. Right. Answer is 1. One comparison. You only need to compare the first element in the A array and the first element in B array. One comparison. The smaller one will be the solution. Yeah. Okay. Then we gradually increase the difficulty. So make k a little larger. So the next try, k equals 2. This time slightly harder, but still not very hard. Okay. 2 elements in A array and 2 elements in B array. We don't need to consider the third one, right? Because k equals 2. So definitely this third one, out of the consideration. And we don't need to consider the third one in B array because it already beats 2 other arrays. So why we need it? Okay? We just want to find the second smallest element. Okay? All right, so for this k equals 2 case, we only need to look at these 4 elements. Then when we do comparison, the first one, which one is smaller? The smaller one will not be the rank 2 number, so we drop it. The larger one of the first comparison, we will use it to compare the next one, either that or that. Depends on which one is larger. The larger element in which array? If it is in A array, then we compare with B element. If it is in B array, we compare it with A element. Okay? Yeah. Next A element. Yeah. And try to see, which one is smaller. The second comparison, the smaller one in the second comparison will be the solution. So you can see the answer is 2 comparisons. That's enough. All right. Now let us consider more general case. All right. So this time we consider general k. But this k, in order to make the discussion a little easier, we assume k less than or equal to the minimum of m and n. Because in this way, we can use the, similar way we did before. Yeah. Because we can take the first k elements in A array for the consideration and the first k elements in the B array for the consideration. Okay, so the rank k must be in these 2k numbers. We do not need to consider the remaining elements. Okay, so that's our first time elimination. We eliminate all these elements. Before we do any comparison, we already eliminate all these comparisons. That's pretty good. Okay, all right. Next, we will use elimination method. Yeah, so we will really try to eliminate as many elements as possible based on our analysis. All right. How to apply the binary search here? When we do comparisons based on the binary search way or style or format. Okay, yeah. So here we pick the middle element of both selected parts of the arrays. Okay, so here the middle one, the median, yeah. So here one comment, yeah, because in many of our questions we talk about the median. So some students ask me, when you talk about a median, do you mean the median with respect to the value, or the middle one with respect to the position? Yeah. Sometimes people get confused. Yeah. That's normal. Yeah. Sometimes I get confused myself. Okay. So the answer is the median always with respect to the value. That means if you sort the whole array, you pick the one in the middle. The position, middle position, only for the sorted array, not the original array. So not the middle position element in the original array. That's the meaning of the median. Okay. But here, both arrays are sorted. So that's why the middle one, the median, with respect to the value position, the same thing. Yeah. So here, no confusion. Yeah. All right. So we select the middle element M1A and M1B. Yeah. So binary search, because binary search we select one in the middle in a sorted array. Yeah. Then we compare a array of, yeah, so here, yeah, here I may use this as the, position number, index number. Okay, so let's use the for the, index number. Yeah. All right. Okay. We need to consider these cases: equal case, unequal. Okay, one greater than the other. Yeah, these cases. All right. So then, how to do analysis based on these cases? How do we do analysis? That is pretty complicated. So we leave it to our last part, B.6. Very complicated. Yeah. All right. So let's stop this part.